Hi and welcome to another Carpenter Tutoring tutorial. I'm Amy and today we're going to talk about how to combine like terms. As a reminder, like terms are any terms that have the exact same variable portions. That means we have to have the same letters for our variables and those variables have to have the exact same exponents as well. If we find that about terms is that they're almost like units. And what that means is if I tell you that I have 5 apples and 4 bananas, I can't suddenly say that I have 5 apple bananas, right? I can't combine them together because they're different things. But if I tell you that I have 5 apples and Johnny has 4 apples, I can say that we together have 9 apples. Combining like terms works similarly in that you can think of the variables as functioning like units. And when we combine these terms together, we're really combining their coefficients. So let's take a look at our first example. We have 8w squared plus 5w squared. What this is really telling me is that I have 8w squareds and I also have 5w squareds. So what I'm really looking at is the combination of 8 of these units with another 5 of these units. Well, 8 plus 5 takes me to 13. And then the variable portion of this combination stays the exact same as what we had seen in our previous terms. So I'll still have w squared. Let's take a look at the next example. We have negative 2z plus 4 plus 3z. Well, as I look at this expression, I can see that I actually have some different terms here, some unlike terms. I can tell that because not every term ends in the exact same variables. I do have 2 terms that look the same. I have negative 2z and 3z, which both end with variables of z. But the 4 in the middle is a constant. It doesn't have any variable whatsoever attached to it. That means I'll be able to combine the negative 2z and the 3z together, but I won't be able to combine their total with the 4. That means I'll have to continue using the 4 as its own term, even when we've simplified this as much as we can. So let's handle the z's first. We have negative 2z plus 3z, again telling us we have negative 2z's and 3z's. In combination, that gives us 1z, which we can show as just z. This would be the combination of those terms using z. But I still have to represent the 4. I just can't combine it with the existing term of z. So I have to continue using addition and representing 4 on its own to give the simplified version of this expression. Let's take a look at one more example that starts to get even more complicated. Our final example is 8m squared minus 5mz plus 4mz minus m squared plus 4. Whew. We've got a lot of different terms here, but we're still going to continue with the same process that we've been using for our other examples. When I have a long expression like this, I like to start by focusing on a single term, and I tend to just go in order with what I see, reading from left to right. As I read from left to right, that means the first term that I see is this 8m squared. So I'm going to look throughout the rest of my expression and see if there are any other terms that end with m squared. And remember, for them to be like terms, m squared has to be the only variable that we see. Well, as I scan through the rest of this expression, I do see this negative m squared later on. That tells me that I can combine 8m squared with negative m squared. Now this seems a little more squared. So as I'm putting together my like terms, I have 8 as one coefficient, negative 1 as the other coefficient. When I combine those together, I'll end up with 7. And then in terms of the variable portion of this term, I need to keep the m squared that we saw in these like terms. Now I can continue in the expression and see if there are any other like terms that we can combine. So the next one that I come across is this negative 5mz. So I'll look through the rest of the expression and see if there are any other terms that also end with mz. I do see 4mz, so that tells me I can combine these two. Negative 5 plus 4 would take me to negative 1. And then I have to keep the same variable portion as what we saw in our like terms. So I'll keep mz. Now we don't usually show a coefficient of 1 or negative 1, so I'll go ahead and erase that number, and I can show this instead as just mz. And the subtraction sign is showing that it's a negative mz. Finally, that leaves just the 4 left over as a term we haven't combined yet. We've used everything else in this expression, and there aren't any other constants for me to combine 4 with. So I'll have to bring the 4 down with addition to stand on its own. As I look at my new expression, 7m squared minus mz plus 4, there aren't any other like terms that I can combine. No variable portions of these terms match each other exactly. So even though I have multiple terms, I know that this is the simplest version of this expression because I only have one term for each variable portion. Well, I hope it's been helpful to go through a couple examples of combining like terms together. As always, if there are any other topics that you'd like to see discussed or questions that you have, please let me know down in the comments. If you enjoy our content, I hope you'll consider liking this video and subscribing to our channel. Thank you so much for spending part of your day with me, and I'll catch you next time.